Good morning, everyone. 2015. This is 4 years ago, a little bit more because it was at the beginning of the year. I left my job and I changed it from a big company, 400 employees, the 33rd worldwide portal in terms of traffic, and then I changed to a very different thing, to a company where I was heading the technical office in one of the cities, and in there I needed to build a team from scratch. So I had a mission very clear, which was that I needed to create a backend team, an operations team that was very strong, because we wanted to make of technology the center point of the company. So this company had several offices in San Francisco, Vietnam, in Barcelona, New York, London, but there were mainly three offices in San Francisco, Barcelona, and Ho Chi Minh. So I started working only in Barcelona because I was the technical director in Barcelona. And we started building a set of services that were for high performance, like a tracking service, or then we had services like analytics, all this kind of cool stuff that we all like to work in. So I was building this team, started from scratch. I hired these two guys that are here in the front row, Daniel and Daniel, because I always choose repeated names so I don't have to make memory. So I had this guy, I had a great team. We ended up being like 20 people, and we started delivering services. The first one was the tracking service. Everything was running fine. We were able to process 1 million requests every minute. So it was quite performance per instance. And just enjoying our time there. It was a great time. Everything was working smoothly until one day. One day something changed the way we worked there. On that day, I felt the flame of the Dracarys behind me. It was the manager, wanted to talk with me, okay? So this guy comes to me and say, hey, Albert, I have something that you should know. We are doing well, we're planning. Come on, guy. Because I don't have a lot of patience. So when I want to know something, it's like, tell me right away. And then this meeting, very long, 20 minutes. At the end, he told me, okay, we are sunsetting our San Francisco office. Sunsetting? I'm not English speaker. You have realized this already. So I was thinking sunsetting. I was imagining me, my wife there looking at the sea, the sunset. Oh, fuck, they are firing everyone. I felt immediate sorrow for them. Well, not much, because in San Francisco you can work anywhere, anytime. So I wasn't that sorry, but at the end they were colleagues, and he told me, but there's more. You need to handle all the technical platform that they were handling. Okay. But there's more. We are also changing the way that we are going to interact with our end users. We are shifting our mobile applications from Vietnam to Barcelona. This means that our team now had to shift from being a backends and operations, super happy, to extend that and become also to a mobile development center. So you can have a magnitude of this tragedy. I come from back-end operations. I've been a developer all my career. I work with systems. I never was in mobile phones. But, well, I was the person in charge, and I needed to do it. Oops. So we hired a team, a wonderful team. We hired initially 2 guys that were working on the application, and we inherited all the code from these Vietnam offices. Okay? And in that moment, we started reviewing the code. We saw that these mobile applications were interacting with a lot of services that were being developed in Vietnam. And these guys come to me and say, we need to rewrite this from scratch. This is terrible. This is everything, copy, paste, bad practices. We don't want to work with something like this. And then they started working on a new application. The problem is that we had to deliver an application that was interacting with microservices that were not being built by our team in Barcelona. So this mobile application had to connect with those services that were on Vietnam. We had a lot of problems there. We had the problems with the latency. The data center was in Singapore, and our end users were mainly in the East Coast and the West Coast in the United States. So this is really a problem. Also, they were changing the contract all the time. So the API would mutate from one hour to the other, and we had no control of what was happening. Of course, that mobile application initially was heavily coupled to those services, and if there were 20 services, the mobile would make use of these 20 services. So the situation was going every day, it was worse, and every day was even worse. Not only because of the technical reasons, but also the communication reasons. Because when you work with 6 hours difference with a country that is completely different to you, the mindset is different, the communication is poor because the language is very, very, very low in all levels. So what I did is I went in a plane, I went there, and I discussed with these guys what should we do. So we had some agreements. We make the plan. But in any case, what I saw in that moment is that they didn't have the experience to work in microservices. They were just starting. They just migrated from being regular PHP developers that were doing WordPress and things like this, and they were shifted to microservices. So we were paying that price. And then, on this street, while I was going to eat, and this is street food, it was in the next building, it was a little bit cleaner. It was good, very good food. Then it's the moment that I decided that we should create our own contract. That's an idea that our architect gave me before jumping into the plane, and then I decided, okay, we need to do it. We need to create our own API gateway so our mobile phones are not coupled anymore with those services. So I went back to Barcelona. We started to develop the API gateway. At that moment, it was built in Scala because our team was Java and Scala developers. And we rolled it out into production. And it was good. It was a custom solution. What we do as developers when we have a problem, we develop a solution. That's what we did. We developed a new solution from scratch because what we found in the market wasn't enough for our use case. So, time passed. I moved out from this company. With all these lessons learned, we started working for ourselves in our own consultancy, helping other companies, having more and more experience. And we released in 2017, I think. I'm right? I'm fatal. I'm horrible with dates. And we published our first version of the KrakenD framework. So today I'm going to walk you through a magical journey. It's magical because I say so. It's nothing else. And in this journey, we'll see how to transition from an on-premise application to a cloud application, from monolith to microservices. Okay? I'll go through some horror stories. Enough, I have to contain myself because I don't want to go out in handcuffs from here. Okay? But let me see how we're going time. I'm speaking too much already, I think. Okay, day 0. Our journey starts here. We have a monolith. We have a user through the internet entering into a monolith. We all know what is a monolith. We have a single application connected to a database, and in this application there is the UI, there is the logic, there is the maybe some additional services, but in essence everything is there. It's also on-premise. It's on-premise. It means that it's in a data center or in our own facilities. We can rent space in Cold, for instance, which is next here, or any other classical rack provider where you hire for a rack, you have the space, and then you start facing those scalability problems. The main problem is always the money. And then you decide at some point, because you are having a lot of problems with agility or scalability, that you want to move to microservices. So when we see that our team is been growing in numbers, we have more and more people into the team, everyone is touching the same code base, everyone is trying to understand why is breaking the changes of the other, we see a slow pipeline, if any. So we have all these problems, and every time we need more and more time to deliver a feature into production. And then we have the scalability issues, where you maybe have some very demanding feature, like, I don't know, a media server, something that is manipulating images, or some heavy process, and just because of that single process, your scalability sucks, the platform goes down, and you need to make the monolith bigger and bigger and bigger because this is just one functionality or maybe 2 or 3. Okay. And then if you are on-premise, an additional problem is, I want more machines. And you call your provider, yes, you have your machine right away, and then 1 month later, this machine is installed in the data center. So it's not very agile, let's say. Okay, so now we know that we want to escape from the monolith, we want to go to on-premise, but we are not sure how to do it. What we need for sure is that we need to choose a cloud provider. I'm not going to recommend any of the cloud providers. I think that there is enough information on the market for you to decide. When we have this cloud provider, we need to decide how we are going to chop and how we are going to cut this monolith in all these on all these pieces, okay? I'll use, during all this conversation, a random example. It could be sort of e-commerce or something where goods are stolen. You could have, for instance, from the monolith, we could go to a catalog service where all the items are in. We could have also promotions, which works with the offer of the day, with discounts, with stuff like that. We also are going to need a basket, and we're going to need a lot of other services to complete this microservices scenario, okay? And of course, we will also need authentication. So now we have decided how many services that we want. We will review that process later. And we might want that these microservices have an internal communication together, because the microservices need to talk each other, they need to fire events. There are a lot of options for the internal communication. The less sophisticated process is the direct and synchronous communication. This is what people use us to do in the first place. So I have these services, this service that needs something and is rushing to ask the other services, and it will block and it will wait until the other services are responding. Then we have queues. We can put a message that is consumed later. This is more asynchronous. We can have polling, which is services asking other services. We have publishes and subscribe. We have also the service mesh. The service mesh is that the sidecar proxy that runs next to all these services and is used to make this internal communication between all these services. Okay? This talk is not about internal communication, but external communication. I'm bringing these topics because a lot of times the service mesh, for instance, is compared to API gateways, or they are different things and with different purposes. So, how we are going to consume these services? How we are going to communicate our end users with our services? Are we going to consume these services directly? Are we going to call each one of the hosts? It's clear that it seems that we need something in the middle. Okay? So, and what happens with authorization? All these services need to implement their own mechanisms to validate and to make sure that the request is right. We need something here in the middle. And knowing that we are going to communicate our end users with our services, what can help us to do that? Certainly, there are a lot of products in the same space that can help you to do that. The first one is the API manager. Do you know what is the difference between an API manager, a proxy with a gateway, or they call themselves API gateways, the API gateways and traditional API gateways, the difference with with service mesh. There are a lot of pieces here with GraphQL as well. What are the difference with all of this? Do you know the difference? He doesn't know either. Okay. I will try to make my understanding of what are these products, what are those products. The marketing has damaged a lot, a lot. So everyone has API managers, everyone has API gateways, everyone is everything. I will tell you how I understand each of these products, and this is my personal opinion. Okay? So, API managers. The API managers are used more in large ecosystems, in large enterprises. They are used to do especially validation of who is using that API in assigning API keys to the end users to put a developer portal to show statistics of the usage of those APIs and this kind of stuff. You have examples of API managers like MuleSoft, which is basically an enterprise bus, or 3Scale, which is a SaaS service that allows you to generate keys on the cloud, and they handle that part for you. And then you have the proxy with API gateways. They call themselves API gateways. Things like Nginx Plus or HAI proxy, which are proxies that have evolved to have cross-cutting concerns solved for you. For instance, you want to authorize calls, you want to rate limit the users, you want a security layer. These proxies provide you this. Then there's the API gateways. I understand the API gateway, the one that is also able to do aggregation of services. And the API gateways knows about the business logic. Okay, it's not in the layer 4. It knows about your business logic. And it knows about the API contract. It generates the contract that your end users are consuming. The users are not consuming what is behind in the services. They are consuming what is inside the API gateway. Then we have the service mesh. Again, it's also here because it's a different product. It's for an entire different purpose, but it's also mixed in all this in this ecosystem. The service mesh is a product for internal communication and is in essence a proxy next to each service that redirects the communication between the services. And finally, there's the GraphQL. GraphQL is HTTP only. It's a very good service that allows you a client, an end consumer, to choose exactly what is the response that wants to get. So, for instance, GitHub is one of the large companies that is using GraphQL in the last version. I think it's the version 4. Why they do that? Because this allows the end user and the integrator to choose exactly what are the fields that they want in the response. So the GraphQL is very good to provide an HTTP API for the end user that you don't know that is going to create its own API. Okay. And now the difference between stateful and stateless, because this presentation is about transitioning with a stateless API. Let's see first this important aspect to consider. Let's begin with the stateful. In a stateful system, the logic relies on an external source of truth. We see here this database. So the database stores all the data of the API gateway, like the limits, the counters, tokens, stuff like this. Okay? And the gateway, the logic part, is out of here. It's these boxes that we see with the gateway letters. So when you need to scale an application like this, you need to scale your database. So you need to make your API gateway needed if necessary, but then for sure you will need to scale your database too. If when you go to a multi-region, which should be something very common today, then you need to have those databases synchronized multi-region. If you add 3 regions, then you even need more synchronization, more communication between the gateway and the database with the other databases. So we are creating a lot of complexity just to provide an API gateway. In a stateless application, you don't have any kind of database. So every node has all the configuration it needs and knows what to do and doesn't need to talk with the other nodes. It's very simple, and it's not complex at all. A stateless system and a stateful system work in a very different way. And because a gateway is a piece that is usually in the middle of your backend consumption, what we don't want is to turn this into the new monolith. In a stateless system, we don't have any kind of node coordination. The nodes do not know each other. They don't need to. They can send data away. They can centralize data out, like logging or metrics or tracing. You can consume that aggregated information outside the system, but the system doesn't need to speak between the nodes. There's no need of any kind of synchronization either. There is no complexity. There is no challenge in multi-region. You can start nodes in 5 regions. It doesn't matter. It's all a thing about the deployment. It's not about the service itself. And then you have the immutable infrastructure. And all of this gives you linear scalability. Okay? You know, you can predict how this is going to work. You know what will be the outcome of adding more machines into the system. It's plain math. In a stateful system, you need to coordinate. You need to coordinate the nodes with the database. You need to do data synchronization. You need this data stored, which is the source of truth, and which becomes the application itself. Then you have to deal with this complexity. And you have this multi-region lag. And you have a mutable configuration. The service is running, and then it receives a request to change the configuration. At that system, at that moment in time, it needs to change the behavior, but how do we track that? Who did this call? When? What happened? In a stateless system, you version everything. You have in your Git repository, or Mercurial, wherever you want, you know when the changes happened and why it changed. If you want a thing like this in a stateful system, then you need to put even more complexity and start to log and start to audit. And so every time you are doing more complex stuff. So in this presentation today, I'm choosing for you the Stateless API Gateway because it's going to help a lot in this process. But before, just a little mention on the proxy. I was mentioning tools like HA Proxy or Nginx Plus, which are proxies with API Gateway functionality, because I want you to show you how this works. So a product like this, what you can do is you can map a series of routes with their backends. The problem is that you cannot only consume from one backend. It's a redirection. It's a one-to-one relationship. So if I choose the catalog URL, I'm going to end up in the catalog service. So the clients are coupled to the backend. With an API Gateway, we can extend those proxy capabilities. We can implement, for instance, the backend for front-end pattern, okay? Because everything that we are going to need, the gateway will provide us in an aggregated way. This is a simplification of the aggregation concept. Let's imagine that we have this call to the front page, and this front page is consuming from 3 services at a time. The gateway is going to do 3 calls, at least, and it's going to take data from the catalog and promotions and pricing services. I'm saying at least because we can stress even more our backend to get more performance and cancel those requests that are still not, that cancel when we have a good one. So the benefits for the client by doing this is that what we get is we get an standardization of the consumed data because we know what the end client is going to consume. We know that we will have a reliable API contract. This API contract is not going to change. What it can happen is that the backend changes, but I can reflect those changes in the API Gateway. But in any case, the end users are consuming the contract that is publishing the gateway. This is decoupled from backend. Of course, it's dependent of the backend, but it's not coupled to the backend. And implements only those cases that are needed by the end user. The gateway also provides us an easy way to consume data that we know that has been filtered or, let's say, secured. Because the gateway can protect us for the malicious use. It will treat also your backend services with respect. It's not going to stress them when they are down or when they are very close. So it's like something in the middle that is protecting both you as a microservice developer from the end user, and it's protecting your services. So it's protecting you both ways. I think I'm going too long. I think you got the concept already. So what are the cross-cutting concerns that we can put in an API gateway? These items that I'm showing here in the box are some of the cross-cutting concerns, not all, because the list is long. The first thing that I want to mention is the transport adapter. It's very important to understand that KrakenD is not only an HTTP server. It can speak gRPC, it can speak MQP, it can consume and PubSubs, or it can consume and produce message into the queues. It can do this translation. So let's say that it's agnostic to the transport. It can aggregate, it can do service discovering, can filter the requests to have less content on the responses. It has metrics, tracings, authorization, circuit breaker, because when our microservice is having a bad time, we don't want to keep hammering on them. We have all kind of security stuff. We can speak several encodings. We can speak XML. We can speak JSON. We can consume from that. We can mix them. So we are giving the freedom to the microservices to choose what are those things that they want to implement. And then we have more. We have rate limiting to make sure that that an endpoint is not abused. We have load balancing, publish description, manipulation of data, stub data in case maybe some I'm going to the backend and it's down and I want to respond some kind of data, even it's fake, to the end user. This is a stub data. We can mirror traffic to another backend that is just ignored, but we want to test it. And queues, and as I said, there is still more. So, migration by example. I'm going to take all these pieces and show you how to do a migration from the on-premise to the microservices. So, first thing, there are different migration strategies. We can choose to just put the gateway and only adopt those new functionalities. So, if we have something that the business said that is new and it seems that it could be its own microservice, then we do it. This option is kind of boring. Then there is the incremental migration. Is I take what I already have, new or what is coming, and I do my microservices one by one, and I make sure that during all these processes, everything is working fine. And there's then the casino method. It's all in. You bet on everything. You rewrite everything from scratch. You put it in production. Have you ever known someone who did that? Me too. So, how is this movement going to look like? We are going to identify a first piece. We need to find what is the first piece that we are going to move to the cloud. So, let's say there is this first catalog. Then we are going to take it, write our microservice, remove that part of the database that was in the monolith, and put it into the catalog. Then we do the same with the second service. We do the same with the third service until we don't have any more services. So the monolith ends up like a Gruyere, right? So we are removing all these pieces. An important thing to notice here is that we are in an hybrid state. So we have information in the monolith still, and we have information in the cloud. And the gateway is going to, the gateway is also inside the cloud, but it's going to take data from both systems. So the migration steps. One, we are going to add to the gateway. This is the first step if we want to add to migrate to microservices with a gateway. It's clear. Then we are going to move the authorization to the gateway. The third step is to break one piece. The fourth is to aggregate that piece of microservice with the monolith, because we are moving away from the monolith, but we still need to maintain those old responses to the end user. And final step is that we do the deployment, and we check that everything is working as expected. So first step, we add the gateway, and we put it as a proxy in the first place. Okay, so we are not adding at the gateway per se. It's just in proxy mode. So everything is coming from the client will be forwarded to the monolith. We are not doing any changes yet. It's just traffic going through. It's important to do that because it's the first step. We will probably need to set up the connection between the cloud service and the on-premises. We want to make sure that this part is working fine. Then we also need to tell to the gateway that we need to forward the cookies. Because remember that an API gateway is not that you are not consuming your services. You are consuming the gateway, and the gateway makes use of the services. So we need to explicitly tell the gateway that the cookies need to be forwarded. And then we replicate the contract. What we are going to do is what we had in the monolith, we create the same endpoints in the API gateway. We want the backward compatibility. So with the KrakenD done, you can see that the configuration is very simple. Here we have a single endpoint, which is the login, and we can see that there is an output encoding, meaning no operation, meaning that everything will be forwarded and the gateway won't touch a single thing about this. If you don't like writing JSON files, or TOML files, or YAML files, then you have this online service that you can host as well to edit online any configuration of the gateway. And at this point, what we have is we have added the gateway in the cloud, we had plugged it on-prem, we are working with the hybrid system, we have defined all the endpoints, it's still transparent for the client because it's not going to notice anything, and the cookies are allowed. And here comes our first story of the day. This is sadly more frequent than I would like to. It's when weak languages are used to produce APIs, things like this happen. If you spot the number 2, which is an integer, okay? When these kind of things happen, the strongly typed languages are in pain. So a mobile application will crash, and you will lose your user in that moment, just because the contract changed. So PHP, for instance, and C#, or Java, or Go in the other side, are these typical scenarios where this happens. So the second step was to move the authorization to the gateway. We are now forwarding all the traffic. We are sending the cookies to the monolith. But what we want to do is we want to remove that responsibility from the monolith, remove the cookies, and start to receive JWT tokens from the client into the gateway. The gateway will decide if that user is legit, if it's authorized to continue, and if it is, it will let it pass. Then we are going to create a new endpoint in the gateway, which is the token endpoint. It's going to use the same login endpoint that we have in the monolith, only that we are going to do to add a small flag, as an example, token equal 1, which is going to change a little bit the logic in the monolith. And when this monolith returns the response and knows that this user is OK, it's going to send us back, and the signing component of KrakenD will sign that, and we will know that this JWT token is valid and is coming from a trusted source. OK. This is an example of a login control in a monolith before any change. We can see here that the user posts to a login endpoint with the user and with the password, and if the login is valid, then we set the session cookie. The kind of modification that we need to do is very simple. We need to do just this addition. If this flag token 1 is passing, we can use any other system, like a header. This is just an example. Then I will generate the JSON token. As you can see, this is a plain text. It's not very sophisticated. And we are going to return that JSON code. OK? So important stuff here. You can see that I've put 30 minutes for the validity of that token. It's very important that tokens are very short-lived. The token can be refreshed automatically by the client without the end user noticing. So it's a good practice to have this very short, because then you will, if you need to invalidate that token, you don't need to handle a huge database with tokens. And this is the simple diagram. The login was valid. Then it's asking us for a token. If yes, I return the JSON. Otherwise, let's keep the monolith as it was. And now we can generate tokens, and now we need to validate them. So we take just the first endpoint, let's say the basket endpoint, and we add the configuration. We add the validator into the configuration, and then we can play here with the roles, or we can do more sophisticated stuff. But this is the simple example. So by doing that, the gateway will make sure that the token is valid, is generated, and is signed by KrakenD, and then it will check, does it have the role user, or does it have the role admin? Then it can pass. Otherwise, it will reject that connection, and no user will be able to do anything with that. So the next step is to retrieve that token, because the monolith was expecting to find data inside the session, and now it needs to extract the data from the token instead. So this is an example of a JWT token. You can see that this is a simple base 64 decode. It's nothing complicated. And here we have the information that we have put. This is up to you to put inside everything that you want. So in step number 2, we added all the endpoints protected by the gateway. Now we only need the authentication header to be passed. We don't need cookies anymore. And the monolith is retrieving the sessions from the tokens and not from the disk. And now we need to start chopping the monolith. The question is where to cut. I cannot help you much with that. I can tell you that what we have seen so far is that there is a scale where the social aspect usually weighs more than the technical itself. Of course, you need to choose the domain of the components. You need to choose the dependencies that you are going to have with your components. You need to know about the latency constraints that we have. You need to know the persistence model. What are the languages that you're going to use for each service, etc. But the size of the team, the experience of microservices within your team, what are your growing plans? How many people is going to be in the team? How many teams? All of that questions matter a lot when you decide your microservices strategy. So, chop your way, take your axe, your saw, your katana, your butter knife, whatever you want, and start removing all those services from the monolith. But please, don't do this. Avoid dependencies over the network. And this pattern is annoyingly usual. A request service that needs another service to fulfill the response. So when you're going to microservices, you need to think that you are in a network. You cannot be looping all the time the other services and wait synchronously until they respond. Of course, there will be some times when this is justified and you need one service consuming from the other. But just don't start to implement this kind of patterns where I go to one service, then with the response of that service, the gateway asks to another service, and this end times, and you are looping to get all the information that you want, okay? Also, size. These are supposed to be microservices. Yeah. Mr. Amazon, Mr. Google Cloud are super happy that you generate a 4 gigabytes artifact every time that you deploy something. Hey, I am a little lightweight microservice. I'm not going to say anymore. It's self-explanatory. Mucho money. So, back to business. Pick the first service to extract. Choose what is the best candidate. I personally start with the authentication service and have the plans ready for the others. Write idempotent and safe services. So a request method is considered idempotent when multiple identical requests have the same effect all the time. And a method is safe when their semantics are read-only and the client is not requesting a change and it won't get a change. So we also see this a lot. I do a GET request, and then something in the background happens and alters the state and changes the database. And when you do the same GET, you get something else. So it's very difficult to work with this. Now we need to aggregate the services. We are cutting, we are doing more services. We need to aggregate them together and put them in the same response that we had before. So the concept of aggregation is very simple. You have one service that maybe is getting the information in XML or JSON, and then you get everything aggregated in any format that you would like to consume. And in this aggregation, you can also do some manipulation, filtering, or grouping. For instance, you want to remove the date field here, or you want to rename discount to save because there is another service that uses the same word and you want to standardize. There are more powerful things that you can do. There is flat map, there is a DCL language. Now in the last version, we even have Lua scripts. And then with all of this, you can create the contract the way that you like it more. So here we have an example of a checkout page that is requesting data from 5 services. This endpoint is protected. It's going to require that the valid JVT token is issued, otherwise it won't pass. And here we have an example of a splash screen, a public endpoint that doesn't need any kind of token because it can serve directly the content that is inside. So one of the things that I sell, because I'm more a Markdown developer today than anything else, is that we can make applications much faster. So one company came to me and told me, OK, why don't you review my application and tell me how would you aggregate all of that and what we can do? OK, let's have a look. I phoned my friend, David, who is an excellent mobile developer, told him, why don't you install this application and do that cool stuff that you do with the man-in-the-middle proxy, and we do a little bit of sniffing of the network. OK. Splash screen, 68 calls. 68 calls for that little spinning in the mobile phone. Do you really need 68 calls to load one? And I thought, OK, if the splash screen there is 68, there must be more. So the onboarding tour took 178. When the application went to sleep and went back, did 208 calls. And with just maybe 11, 12 clicks, we were generating 800 calls. So yeah, you need to aggregate something at some point. You need caching, and you need to do a lot of stuff here. So if 11 or 12 clicks produce these 800 calls, imagine a full session of real people trying to sell and buy and go back to the product, and this I don't like, I discard, I get out from the cart, I add again. So, and they felt like the application was slow. Good feeling. So, also avoid the take-it-all pattern. Do not let that the client and the gateway, sorry, because they are telling me I'm out of time, and I think they're not even in the middle. So OK, and this stopped working. Nice. Don't do this. So don't let that the client gives 10 megabyte responses all the time. Just filter that information. You can also connect to message brokers. With KrakenD, there is a lot of the backends that we support. It's not just HTTP. And as for deploying, I will go very fast now, and it's also very simple. KrakenD has a single configuration file that you just need to copy in your Docker file and deploy that artifact. It doesn't take not even 40 megabytes. You can deploy anywhere, in any platform, in any orchestration system. You can also use RPM or deb packages. And then, think about adding multiple API gateways, one per client, maybe one for micro frontend if you have transversal teams. And it's not necessarily the point of entry. It can be another microservice that is consuming data from the other services. As per observability, we have all kinds of graphs. You can export your data anywhere you want, Instana, Zipkin. It's also one click. You can choose where to go, Prometheus, X-Ray, etc. And there is all these metrics that you can use. And then when we reach this point, we start again. We take another piece of the monolith, we aggregate, and we deploy. The last part is shutting down the monolith. It's not necessary the effort of ending with a monolith, and maybe we want to keep a little monolith. This is a frequent case. And that's it. The migration is done. So 2.5 years ago, we built from scratch this API gateway. We learned it the hard way. We did consultancy with a lot of companies. We learned a lot in this process. We keep adding more and more stuff to the product. We provide an open source project that brings all these enterprise features for free. We are probably the only company in Barcelona that works 100% with Go language, and probably one of the few that works 100% remote with all the pros and cons. And just some last numbers. We have 3,000 users on the month on the website, almost 1,600 people editing the configuration online. Our clusters report 1,311 years uptime in the last 9 months. We are spread in 437 cities and within 73 countries. And just now, I'm over my time. I want to say thank you to all of these, especially the early adopters from all these companies that you hear and more. And thank you very much for being here today. I don't think that we have any questions. Thank you.
So I think we only have time for a very quick one, and otherwise just try to grab Albert while we are setting up the Google guys.